Hello class, we're now in section 1.3 and we're really getting into the meat of the situation. All right. 1.3 is where I'm going to introduce polynomials, okay? And so I'm just going to start off with an example before I actually do a polynomial, like explain what they are, okay? So a polynomial is something that looks like this, okay? We have basically powers and variables, like x's, okay? So these are what polynomials are. And specifically, I'm going to show some fancy vocab words. So this 3 is called the degree, okay? Because it's the biggest power. All right, so the degree of a polynomial is the biggest power you see on x, okay? Now, the term that has the degree, all right, this is called the leading term. And that's, first of all, it's mostly because we write it first, but it's the one that has the biggest power. And then specifically the 2 here, this one is called the lead coefficient. Okay, so the lead coefficient. And the 4 also has a special name that is called the constant. Okay, so these are parts of a polynomial. And so it looks like this. So again, before I kind of write down the really huge formula of what a polynomial is, here's examples of stuff that isn't a polynomial. A root. Okay, any square root, cube root, fourth root, roots are not polynomials. Also, these things. Okay, fractions, negative powers. Okay, these are not polynomials. Okay, only positive powers of x's are polynomials. Okay, and then so let me write down the formal version. So a polynomial p of x is going to equal to a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus a sub n n minus 2 x to the n minus 2 plus dot 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 plus a 2x squared, a 1x1, a 0x0, but remember, anything to the 0 power is 1, so we don't really write that one down. Okay, and so here's a polynomial. This is all of them. This is what they look like. We can recognize the parts I talked about, right? So this thingy is the constant, the one at the end without an x power, or with the x to the 0 power. Here's the leading term. We can see the degree is n. Okay, the leading coefficient. And anything between pluses, these we just call terms. Okay, a term is a thing between some pluses or minuses. Okay, and so this is a polynomial. And then we have special names for them. Again, you could like read your textbook on this, but it's not very much important. A monomial, okay, a monomial is a polynomial, okay, with one term. So like x, or like 2x cubed. Okay, those are monomials. Something we work with a lot are binomials. Okay, so a binomial is a polynomial. Polynomial is a polynomial with 2 terms. Okay, so these are things like x squared minus 2, x plus 5. Okay, things with 2 terms. All right, so we have introduced polynomials. Now what can we do with them? Okay, first we're going to learn how to add and subtract them. Okay, so addition and subtraction of polynomials. Okay, and for here, everyone always uses the phrase or the saying combine like terms. Okay, so I need to explain what that means, okay? So here's an example. Okay, if I have x cubed plus 2x squared plus 2x minus 1, okay? And I'm adding that to the polynomial 4x squared plus 5. Okay, what do? Well, I combine like terms. So what are like terms? Like terms are terms with the same power of x, okay? So here I have a 2x squared and a 4x squared. Those are like terms. Okay, so then I just add the coefficients. So I get 2 plus 4, 6. Okay, and then if there are no like terms, like here I have an x cubed, this one doesn't have anything. So basically nothing happens. It just kind of falls down. Okay, here's a 2x, this one doesn't have anything. And then the constants are like terms. So -1 plus 5 is 4. And ta-da! This is the answer. Okay. So really not that hard. Now subtraction is a little annoying. Okay, so if I have x cubed plus 2x minus 5, okay, and I'm subtracting 2x cubed plus 7x squared minus 5x minus 2. Okay, this parenthesis is extremely important because the parenthesis means that I have to distribute this minus sign to all of the terms in the second one. Okay, so I'm just gonna rewrite this, even though I would, I would actually not rewrite this if I was doing it. But, just since this is the first time, show some work, okay? So it changed all of the signs, right? All of them flipped. Okay, and then now I'm just gonna, x cubed negative 2x cubed, that is negative x cubed. Okay, 2x, 5x, that is 7x. Here I have this negative 7x squared. That's the only x squared, so that one I'm just gonna put there. And then negative 5, 2, that's negative 3. Okay. And ta-da, subtraction. Okay. All right, adding, subtracting, not too difficult. Okay. Next is multiplying. Okay. So multiplying polynomials, basically you just need to remember the word FOIL. Okay, I'm sure you have heard of the word FOIL. I'm sure you know how to FOIL. FOIL is an acronym that stands for first, outside, inside, last. Okay, this is the secret. Okay, this is how we multiply polynomials, or at least this is the secret to multiplying binomials. Okay, which is what we're gonna be dealing with all the time. So a plus d and c plus d. So I'm gonna follow FOIL. So first, a times c. Outside plus ad. Inside plus bc. Okay. And then last plus last plus bd. And this is the answer. This is the FOIL. Okay. So That's how you FOIL. Okay. Specifically though, here now you know how to do this, right? A plus B squared is A plus B, A plus B, and then we're gonna FOIL. So A squared plus BA plus AB plus B squared. Because of the commutative rule, we know those are the same thing. So plus 2AB plus B squared, and ta-da! Okay. I encourage you to just memorize this. Okay. If you don't memorize this, you probably will do this enough that you're gonna accidentally memorize it. Okay. But we're definitely gonna be squaring binomials all the time. Okay. So besides that, example, so let me use that, right? 3 plus x squared. Okay. So 3 plus x squared is going to be 9 plus 2 times 3x plus x squared. So 9 plus 6x plus x squared. Okay. This is an example of this formula. Okay. So it just makes life a little faster. You know, foiling is kind of slow. So it's understandable how some people don't want to use it. Okay. And then here's an example of, I guess, well, we have time. So yeah, let me just do another FOIL example. Okay. So first, you're gonna get 15x squared outside. You're gonna get plus 20x inside minus 3x out last minus 4. Okay, and you got to simplify the middle parts. So that's a 17x minus 4. Ta-da! Okay. Now I have to teach you how to multiply anything that's bigger than two binomials. Okay. So here, I have this. Okay. And the rule for multiplying polynomials when they're bigger than FOIL, okay, is I'm just going to say multiply everything by everything. Okay, so what do I mean? Is you take this one, okay, and you're going to multiply it to all three of these terms. Okay, so you're going to get 2x cubed plus 6x squared plus 4x. Then you're going to take the other thing and you're going to multiply it by all three of these. So it's going to be x squared plus 3x plus 2. And you notice the way I wrote them specifically was weird. Like I stacked them like this because then, right, technically there's a plus here. So you have to like combine them. So the answer is 2x cubed plus 7x squared plus 7x. Oh, that's a funny coincidence. Plus 2. Okay? And that's the answer. You probably won't be doing this a lot, okay, if I'm being honest. Okay? Now, I'm going to go over some very important formulas, okay, that you can choose to remember. If you don't, they probably will get stuck in your head anyway. Okay, but this is called the difference of squares. This is by far the most important formula. Okay. This would save you a ton of time. All right, difference of squares. Okay, so you can use this to FOIL fast, right? Because if you notice, these are kind of like conjugates. So like the middle part disappeared, right? That's the magic of it. But we're also going to use this when we factor, okay? So here are the other two formulas I kind of talked about already. It was a plus b squared. This is a squared plus 2ab. I don't know why I use capital letters. Plus b squared. And so what happens when you use a minus sign? The only thing that changes is this minus sign in the middle. Okay, so these two, not that hard to memorize. Let me make the minus sign more obvious. The only difference is this minus sign. Okay? All right, and now we're going to move on to the main point of the section, okay? And that is factoring. Okay, so you need to become pretty good at factoring. So, a couple of them is, well, I just kind of talked about this, is one way to factor is that you have memorized a formula, like the difference of squares formula, okay? So here's an example of using the difference of squares formula. All right. And there are many, many formulas you can choose to memorize. So an example here is this is the difference of cubes formula. Okay. So I have not taught you this formula. You can choose to learn this formula from the internet or your textbook. Okay. But it's useful sometimes. And there's like a difference of fourth power. It goes on. They get less important. The most important is the difference of squares formula. Okay. But most of the time, it's not gonna be some special formula like this, okay? You're gonna have to just know how to factor the traditional way. Okay, so we're gonna start this with an example. X squared plus 7x plus 12. Okay. And so I learned it a very traditional old school way, which is what I'm about to show you now. Where you just kind of put two parentheses, okay? And because this is a 1, it's pretty easy because we know it's going to be an x and an x, okay? And you just need to figure out what numbers these need to be, okay? So what you do is you kind of want to think about FOIL, okay? You know that 12, you need all of the ways to make 12, okay? So like 1 times 12, -1 times -12, -3 times -4, 3 times 4, 2 times 6, -2 times -6. So right, you should think of all of these in your head. And you want these two numbers, okay? You want them to multiply to 12, okay? And then here's the big deal, and add to 7, okay? So you could look at all of these, and hopefully after a while you will realize that you want to pick these, okay? If you choose +3 +4, it works, okay? And you can double check this because we can FOIL, right? So x squared plus 3x plus 4x plus 12, right? This is 7. So ta-da, it works, okay? So this is how I learned to FOIL, is you just kind of factor the constant term, okay? And you needed to add to the middle term. Now, what I advise, because we're on the internet anyway, is if you want a more concrete method, I encourage you to punch this into the YouTube. All right. I hear very good things. All right. The tutors in the tutoring labs, when they existed, would definitely say good things about the AC method for tutoring. I mean, for factoring. Okay. So I encourage you to look up the AC method if you don't like this way. But let's do some more factoring. Okay, so here's another example. X squared plus x minus 6. Okay. So again, x, and now I want something that multiplies to negative 6, but adds to 1. Okay. So since I have a negative sign, right, that means one of these should be a plus and one of these has to be a minus. Okay. And then for 6, you kind of just think about it and you're like, wait, if I put a plus 3 and a minus 2, then it works. Okay. Because obviously 3 times negative 2 is negative 6. And then if you do the double smiley face check, all right, or the double upside down rainbow, you're going to get 3x minus 2x equals x. And it matches. So you see that's good. All right. And so now I encourage you to look up section 1.3. Okay, there's a whole bunch of special formulas if you want them. Special factor formulas. All right, you may or may not use them, but they're typed up in the notes if you want to see them. Okay. But yes. Moving on to the last kind of factoring. Okay. So this you need for the AC method anyway, so you should be paying attention here if you plan on Googling the AC method. All right, it's called factoring by grouping. Okay. So we do this when we have more than 3 terms. Right here, in both of these examples, we had 3 terms. Here we're going to have 4 terms, okay? And we're going to notice something, okay? Basically, factoring by grouping is kind of what its name sounds like. We're going to group these into 2 pieces, okay? And then we're just going to factor out as much as possible from each little piece, okay? So from here, I'm going to factor out an x squared, and then I get an x plus 1 in the inside. Okay. From this one, I'm going to take out a 5. Okay. And so here's where you need to check if you've done this correct. All right. To factor by grouping, you need these to match. Okay. They need to match. Okay. If they don't match, you need to check that you did it correctly, that you can't take out anything more, okay, or less maybe. And then if it still doesn't work, then try grouping differently, okay? Maybe like group this and then these two or something, okay? All right. But they do match, okay? So then what you do is basically you factor this, okay? So x plus 1, and then the other thing is the leftovers, or what you took out. So x squared plus 5. Okay? And that is that's factoring by grouping. Okay, so let's do another example. Okay. One more example of factoring by grouping. So here I have 2x cubed minus 6x squared minus x plus 3. Okay. So I'm going to group these two. Okay. I'm going to take out a 2x squared from the first group. So that leaves me with x minus 3. And then from here, I can kind of already see what I want. Okay, so I'm going to take out a minus 1 to get an x minus 3 here. and then they match, so we're good. So x minus 3, and then this thing, 2x squared minus 1. Okay? Now, technically this, you're not done. This can factor. Okay? I would not force you to factor this, probably. But it's a difference of squares. Okay? So if you plug this into the difference of squares formula, you're going to get minus 1 plus 1, and then you're going to get square root of 2x square root of 2x. Okay, and then this is the final answer. Okay, so the difference of squared formula can always come in useful. Okay. All right. That's it for chapter 6 point, well, section 1.3, excuse me. I encourage you to practice a lot. Okay. Factoring is a very essential skill. All right, you're gonna need to be not only good at it, but preferably also fast. Okay. So go through your notes, go through the study guides, learn how to factor, go on the internet, Google the AC method, okay, if you don't like this style of factoring. But this is definitely one of those things where just practice makes perfect, and you should definitely practice factoring, okay? All right, well, that's it for today, and see you next class.